Okay, hello and welcome back to the Basic Python course. This is session 7 on modules. So last week we got to know functions, and today we will get to know modules. And before we start, I want to briefly review the concepts that we'll be using in this session. So last week we learned how to write functions in Python. So functions are objects in a Python code which accomplish certain tasks and which, as we have seen, have input arguments and give some return value. And functions are different from modules. So module will be a collection of functions. I told you last week that you can not only use a function repeatedly in the same script in which you define it, but you can also use, in Python, you can also use functions from outside the script, within another script, by importing the file in which you have defined the function as a module. And this is what we will be talking about today. So for the purpose of this lecture, I'm going to distinguish between scripts and modules, where script roughly means the main program which you're writing, and a module roughly means the collection of functions which you are potentially referencing from your script and which you are using in your script. We will, however, see that the distinction between scripts and modules is not sharp, because modules can also be run as scripts, as we shall see later. So once again, there are a few advantages of structuring your Python code according to the structures Python offers you, which in this case means to separate the functions or tools which you want to be using from the code which is using those functions or those tools. One of the advantages is, of course, clarity. It often makes sense to separate the tools which you're defining from the code which is applying these tools to a given problem. And having the tools and the application of the tools in separate scripts, in separate files, which will be a script and a module today, helps the reader of your code to understand or get a better impression of the structure of your program. Second, and more importantly, there's the advantage of portability if you're writing modules. So once again, if you are sharing your code with somebody else, they don't have to copy and paste your written functions into their own code in order to have these functions available. This violates the this violates the dry programming principle. Don't repeat yourself, and it's error prone and so on and so forth. But instead, those others will be able to use your functions by just importing your module. And how that works, we will see today. But before we start, please download the file initials from the Moodle. I will show you where it's located. So in the Moodle, you can either download it from the example programs section, or you can directly navigate to session 7 and then download this module initials. It will be good if you have that somewhere on your computer and then also change to that directory in Python, because this will be advantages for the demonstrations that we will be doing today. So I have saved the file initials in this directory, and I have here also another script which is called IDs, py. And the idea is now that I run this script and explain a bit what it's doing. Yeah. So going to press F5, and then the script asks me to enter two names. I'm going to choose my own name as the first name and similar name as second name. And the program then gives me the following output. User 1 will be called your Zoc, and user 2 will be called your Zoc. So what the program was doing is it was running into a loop. So it was calling the function getInitials, which we wrote last week, for both names with different number of starting letters. So from 1, which would be the default initials, up to the first 4 letters from each name, first and second name. And as soon as the initials of those persons become different from each other, it would escape from the loop, which in this case happens after the first 3 letters have been taken from each names, because there's a difference between Johann and Johannes at the 3rd letter. Okay, in case it would not succeed to give different initials because the names are even more similar or identical, then it would simply add the numbers 1 and 2 to those initials in order to be able to distinguish them. And finally, there's a result message which is being printed and which we have already seen here. Okay, so as you can see, this script is using the function getInitials that we wrote last week, but it's not, the function getInitials is located nowhere in the script. Instead, it's being imported, which you can see here in line 12. And the way this works is rather simple. Simply type import initials. Be aware that the module which you are importing and which we will be having a look at in a moment has to be located in the same working directory. So I could, for example, not import a non-existent module. In this case, I would get an error simply because there's no module called non-existent module in the current working directory. Another important point is that module names should not contain spaces. So as you can see here, Python regards this as separate variables or names being called rather than one name. So just like variable names and function names, please don't have spaces in the names for modules. If you want to have separation between words, use the underscore instead of a space. So this will also give an error because it's invalid syntax in Python. Okay, but the first command which we were running succeeded. So at least we didn't get an error message. And we imported the module initials. And what that means is that this module, which we are importing, is being run. And everything that is being created, variables, functions, and so on, are being put into the variable space for further use. So in theory, we should be able to use the function getInitials. But apparently we get an error. Name getInitials is not defined. And this is because when you are importing a module in Python, by default, Python puts all the functions from that module into its own namespace. So what does it mean? That means that the function getInitials is available to you in the following way. Initials, that's the name of a module, dot getInitials, that's the name of the function. And then you can optionally supply input arguments. And we get a result. You can also try to use the keyword arguments to see how that works. Okay, perfect. So you might be wondering, why is that? Why is Python using namespaces instead of just making the function getInitials available under the name getInitials? Well, the reason for this is that this keeps things relatively tidy, especially when you're writing larger programs later on. So namespaces prevent uh, overriding. Um, Imagine a situation in which you, in your script, define a variable called x, and then later on, you are also importing a module where also a variable x or maybe a function x is being defined. And in that case, if we didn't have namespaces, the x from your script would be overridden by the x from the module that you're importing, or the other way around, if you first import the module and then later on redefine the variable x. Another example would be that you have two modules, let's say module A and B, um, and they both contain um, slightly different version of the same function, which, however, are called the same in these two modules. Then if you wouldn't have namespaces, the function would be overridden by when you're importing, as soon as you're importing the second module. But because Python creates this namespaces, you have the functions from different modules available under different names. So in this case, for example, it could be that you import your modules as module A and module B, and the same function or the function of the same name is contained in both, then this function would be available under these names. Similarly, if you have defined variable x and there's also a variable x in a module which you're importing, it would be available under this name within your script. Okay, there is a way to get a function into the main workspace without using namespaces. And this is called a star import. So what you're doing there is that you write from initials import star. This is why it's called star import, due to this star or asterisk symbol that we also use for multiplication usually. So if I type this, I will be able, other than before, to use the function getInitials from the main workspace. So this means, once again, just like with the general import, that the module which you're importing is being run, everything is being executed, and everything which is defined inside the module is written into the main workspace rather than its own namespace. Although I've just shown you this so that star imports are available, you should generally avoid this. So please don't use star imports. Star imports are considered bad practice because you never know how much things are being contained in a module, and if there's a lot contained in a module, this can cramp your main workspace and make things very untidy. Star imports should usually be reserved for little demonstrations or very short programs. So for example, sometimes when you find tutorials for a certain package online, you will see star imports. That doesn't mean that star imports should be used in your program, but it's just for the purposes of a very short program and demonstration that this simple form of importing is being used in order to avoid the namespaces. If you don't want to have namespaces, and only use particular elements from a module, you can work around this problem. You can use selective imports. So this would mean that you write from initials import get initials. And in that case, the things which you are importing are also be put into the main workspace so that you don't have to write down a namespace when calling them. But you are being explicit about what things you want to import from the module, and nothing else is being imported. So in that case, the function getInitials is also available in the main workspace. One option which is kind of between the default way of importing and selective importing are renamed imports, because often with default imports, the problem is that the commands become very long. Yeah, it appears a bit protected to write initials dot get initials and then the input arguments. So you can work around this by using the following syntax: import initials as ini. Yeah? So you're importing a module and then we'll write the word as, and then you are picking a shorter name under which you want the tools from this module to be available. So if I do this, I can type ini get initials, and this will make my commands and command lines a bit shorter at least. You will often see those kinds of renamed imports with third-party packages. For example, if you're working with numerical data, you will often encounter import numpy as np. So numpy contains a lot of operations, mathematical operations for matrices and vectors and so on. And it's then very tedious to always write numpy and a bit shorter to just use np dot and then whatever function you want to use from numpy. This is one of them. There's also matplotlib, which is often imported as mpl, even more shortening the name of the module and the name of the namespace. And yeah, so as I said, this is a way of bringing a bit of the programmer's choice into how the namespaces are called and make your commands a bit shorter. These two, by the way, NumPy and Matlob, are third-party packages which are contained in the Anaconda distribution. So if you have installed Anaconda and are working from Spider, these packages are available to you without you having to install them. Okay, so to summarize, there are 4 ways of importing a module. We have just import module, where module is now the name of a certain module. This is the general or default import. Then we saw that there were star imports, which import everything from the module into the main workspace. Then there are selective imports, where you can specify which variable or function from a specific module is being imported. And finally, we had seen renamed imports, which means that you usually replace the longer name of the module with a shorter name in order to make your code a bit more compact. Okay, great. So you might have noticed that the way in which we are calling modules, or in which we are importing modules for later use, is similar to the way how methods were used. So remember that methods were specific functions attached to certain data types. For example, if I define the username, which is a string, then I have all string methods available for this variable, and one exemplary string method is upper, which simply takes the string and uppercases all the characters, and then returns the modified string. Okay, great. So similarly, we were importing initials and then wrote initials dot get initials and some input arguments. So what that means is that for both, we have something and then a dot and then something belonging to that first thing, which is being applied for this first thing. And the analogy is actually intended. So in Python, each variable has its own namespace with functions available for us. So I was referring to this initials as a namespace, but you can also think of username as soon as it is defined as a string as a namespace for which a certain set of tools is available. And we also know how to access a list of these tools. So you might remember that we could call dir and then the name of the variable. And this gives us all the methods which are available for this particular variable. So there's always these double underscore methods, which you can ignore for the moment. I will say something about them later on. And then there are the usual string methods. For strings, there's a lot of methods, which is why this is a good example. So if we can use dir on variable names, being considered as namespaces, maybe we can then also use dir on namespaces belonging to modules. So let's try that out. I want to type dir initials. And what I get is this. So that's the list of methods or tools available for the module initials, for the namespace initials. And we see that there's the function get initials, obviously, because we were already calling it by typing initials dot get initials and so on. But there are also some special names. Special names are always the ones which start with double underscore. And here we have some special variables. So let's just check them out. I already told you that the double underscore methods, names, or variables are representing Python's behind the scenes workings, and they are controlling the inner workings of Python. So let's just see what we get when we call them for initials. So let's start with initials dot double underscore file. And if we type this, we just get the file name of the module that we were importing. So that's pretty straightforward. And then another example is initials dot double underscore doc. And this is, as you can see here, the doc string, which has been written into this module or into the Python script representing this module. So as soon as a module is imported, the doc string from this module is written into a special variable named doc, which can then, for example, be printed. Let's also check name. So what is the name of initials? It's initials. And this is kind of underwhelming because what should it be good for to know that the name of the namespace initials is initials? That seems like a vacuous information. Yeah, at first glance, it seems a bit useless to store the name of the namespace into a variable double underscore name belonging into the namespace. But I want to explain you why this is. So for this purpose, let's call dir, but this time without an input argument. So we're just typing dir parentheses, no input argument. And if we do this, we again get a very long list, just like for the string. because there's a lot of special methods. We, for example, also see that there is username, which is a variable that we defined earlier, which is in the variable explorer and which is located in the main workspace. We also see that there is initials, the module which we're using, and there's get initials from the selective import that we were doing earlier, and basically all the variables that we already created during the sessions. But then you already see that the main workspace also has a property called double_names. So let's ask what the name of the main workspace is. It's main. That's great. Because what that means is that we can check whether we are in the main workspace or whether we are inside the module. So have a look at this check. Name underscore equal to main double underscore. And this is true. However, if we would be running this inside a module, it would not be true because, as we have seen further above, the name inside the module is the name of the module. So it's not name. And this is very useful when you want to, into your module, include a brief section testing this module. But before I show you this, I want to open another file, which is called Slim Shady. And I will first now, so I will run this program in two different ways. First, I will import it. I will use the general import here. And as we know, importing a module runs this as a script and writes all the functions or variables potentially defined inside the script into its own namespace. And when I run this, I get the following output. Hi, my name is what? My name is who? My name is Slim Shady. Okay, that sounds plausible. But now let's run this program in another way, namely by just going into the editor and hitting F5. So meaning that it's just being run as a script on its own. And then we get a different output. We get, hi, my name is what? My name is who? My name is main. Why? Because when we were running the script, we were located in the main workspace. And the name of the main workspace is main. So here the output was not the name of the module, but the name of the main workspace. So here in the initials module, you can see how this is being used. In the bottom, there's a section called test the function, and it starts with if name equal to main. So remember when we are running this script, this is equal to main. If we are importing this as a module, it's equal to the name of the module. So let's try out this once again. I already did import initials, and we know that nothing is happening, at least no output is being generated, but the function is only put into the namespace initials. But now if I'm running the function, this check or this condition is found to be true, triggering the next commands. And the next commands are testing the initials function with examples. So we are here printing the initials of Mildred Bonk, first in the default way, giving this output, and then in slightly modified way, giving this output, MB and MIBO. Okay, so as I said, this is useful for testing a module. If you want to debug and see whether the function that you're writing already accomplishes the task which you want it to do, there's no need to switch files. Yeah, you don't have to write your module, save it, move into your script, call the module, test the function, but you can directly write your desired checks into the section and then simply run the module as we have seen. And at the same time, this doesn't disturb others when they are using your module because they will be typically doing this. When they're doing this, your debugging and your checks and your tests are not being run. Great. So this was it for special names, file, doc, and name. And then there are also special methods. So for that, I want to write a brief little program. So I'm gonna define a string, which will be a single word, the word hello. And then I'm gonna iterate through all the methods which are available for this object, which are string methods, as we know. And for each method in this list, I'm going to check whether it starts with a double underscore. And if this is true, then this if condition is being triggered. And then I'm printing the name of the method. I'm going to save this. And run it. Okay. And now I'm only seeing the double underscore methods belonging to the strings. So I told you earlier that you shouldn't worry about those double underscore methods, and you should continue to not worry about them. But I want to, just illustrate 3 of them in order to show you or to demonstrate you why they exist at all and what they are good for. So I want to check add, I want to check equal, and I want to check get item. So example, you know that we were able to use the plus sign to concatenate string, to add strings, so to say, which just means to put them one after another. For example, the output of this would be this. And the same would be achieved by calling the special method add. And then the other string, which is to be attached. And this gives rise to the same output. Here's a second example. So we saw that we can compare strings with the equal notation. So this would be true. And the same would be achieved by calling the special method equal, and then with the word to be compared as an input argument. And this also gives true. And one last example, we also saw that strings are sequences, like sequences, meaning that they are sequences of characters, and these sequences are ordered. So we can access the first item like this. And the same could be accomplished by typing word double underscore get item and then number of the item or the index of the item as an input argument to this special function or special method once again. So this would give the same output. So by doing this, I'm not saying that from now on you should like replace all your plus operations with double underscore add, or that you should replace your checks for equality with double underscore equal, and so on and so forth. I just wanted to show you this so that you understand what these special methods are good for. For example, if we define a new data type, we would have to fill the add method with some life in order to tell Python how the plus sign should be handled when it's being used to combine data types, to combine variables of these data types. Because the plus means different things for integers than it means for words. Okay, so once again, please avoid using special methods in your program and please forget about them. Now again. Great. So with that, we are done for today. There are homeworks again. So if you check the online course notes for modules, you see 2 exercises here. One of them is just transforming a function that you wrote earlier into a little module. And the second exercise is then to write a program or a script which is using this module and importing it on the way. Okay, that's it for today. I'm saying goodbye and I hope you enjoy the other videos as well. Thank you very much.